Are you serious, Brooklyn?
Everybody say hi, Liddell.
I
They don't care about you, Liddell.
Oh.
All right.
Liddell!
Okay, shh. Be quiet. Goodness
Hi.
sakes.
Keaton.
You need Sokotoa
Shut up.
for this lesson.
Nasty.
Sokotoa, applications and models. Solving right triangles. Example. Solve the right triangle. When it says that, you are finding everything that you do not already know when it says solve the right triangle. So you need a capital A, a capital B, capital C, lowercase a, lowercase b, lowercase c. What's the difference between?
We did this in quarantine.
What's the difference between capital letters and lowercase letters?
Capital is degrees.
What do we have to do now?
And the angles.
These are the angles.
The other one's sides.
And these guys are the sides.
Hey, somebody already wrote it.
Okay, be quiet. So, some of the things we should know already. What do we know?
We know big A.
We know big A is 34.2. Okay.
Little B.
We know little b is 19.4.
And big C is 90.
And we know big C is 90. Okay. What else can we find very easily?
Big B.
We can find big B because they all have to add up to be 180. These guys all together are 180. So, really, since we know that one of them is 90 already, really A and B have to add up to be the other 90. So I would just do 90 minus 34.2. Right? 90 minus 34.2. Can you do that in your head?
No.
What'd you say?
No. 90 minus 34.2.
55.8.
55.8 degrees.
I was going to do it. Give me another one.
Okay, just wait. We will. All right, now, how do I find little a and little c? It's not that easy.
Cosine.
I have to do sine, cosine, and tangent, okay? So little a, I have to use this, I have to use a, and then I have to use one other side that I know. Well, the only other side I know is 19.4, okay? And then let's pick an angle. So I can either use 34.2 or I can use 55.8. Never use the right angle.
That'll be weird.
Because then it won't work. So 34.2, okay, let's talk about why it won't work. If you pick C as the angle, which one is the hypotenuse? If you choose to use C as your angle that you're focused on, which side is the hypotenuse? Little c. Then which is the opposite? Also little c. That's why you cannot pick the 90-degree angle. Does that make sense? You have to choose one of the acute angles because this guy, little c, would be the hypotenuse and the opposite, and that doesn't work. So let's focus on the 34.2 angle, okay? And we want capital A, or excuse me, lowercase a and 19.2. So we want the opposite and the adjacent, right? Opposite, adjacent, so we're going to use the trig function tangent. Okay, and tangent of what? What do we do tangent of?
Of x over 19.4.
Wait a second. Tangent of what? What goes inside the tangent?
34.
34.2. The angle always goes inside of here. And we do A or X, whatever you want to call it, over 19.4. Okay, now if I'm solving for A, I want to get this A by itself.
You gotta multiply 19.
Multiply by 19.4. Okay, do you want to be in radians or degrees?
Degrees.
Why degrees?
Because it's degree.
34.2 is a degree measure, so you want to do that. So 19.4 times tangent of 34.2.
I don't think Brooklyn should be at school today.
Or Cody. Cody is actually coughing. 13.2.
Is it 13.2?
It's 13.2.
Okay, so lowercase a is 13.2.
Brooklyn, you should leave.
13.2. Lowercase c. Okay, I'm going to do the same thing again. I'm going to erase all my stuff.
Pythagorean theorem.
I forgot how to
Hold on.
use this calculator.
You can do the Pythagorean theorem if you want to. You want to do that?
Yeah.
Or would you rather do another trig function?
Fine. We could do.
Let's do another trig function. Let's do, so I'm trying to find lowercase c, and I'm going to use 19.4, and I'm going to use 34.2. So what are these two sides?
Hypotenuse and adjacent.
Hypotenuse and adjacent.
Cosine.
So I need cosine,
Cosine of 34.2
right?
equals 19.4 over x.
Equals
And then
19.4 over c.
then
Or x.
do 19.4
Okay, now,
divided by
here's the tricky part. Since your c is on the bottom, do you guys remember what you do? You flip the two. So like this c and the cosine flip with each other. So you have c is equal to 19.4 over cosine of 34.2. Do you remember doing that?
Yes.
Yeah? Okay. So divide those guys out, and then you'll get what lowercase c
Is
is.
this the last lesson?
Oh,
Yes.
I cleared the memory and I don't even know how.
That means test.
Wait, so that means test Thursday? And
Probably
Friday?
probably Friday.
I'll bet.
We'll review tomorrow and Thursday.
Oh, that sounds like a perfect day to be
Ew,
sick.
that's the chemistry test
Friday?
too.
Okay,
Yeah.
19.4 divided by cosine of 34.2. What'd you get? Lowercase c.
Oh, I just
What is
didn't
he?
even do it.
You're
Was it?
sick today, so.
The cosine of what?
I want to, but
34.2. 19.4 divided by cosine 34.2.
What's that question?
I'm doing the
What are you
math
asking?
again.
Shh, just wait. 23.5? Yeah? Okay. Which side should be the longest side? The hypotenuse. Is that consistent with what we have?
Wrong.
Yes, so always kind of check to make sure that that like makes sense, okay? The order of the angles. Which one's the smallest angle? A, is it opposite the smallest side? Yep. The biggest angle is 90. Is opposite the biggest side, 23.5. That's the way that it goes.
That's right.
Okay. So that's the way that that works. Okay. Find a side of a right triangle. Okay, so, oh my gosh, they give us some weird things, and I'm going to rewrite this. A safety regulation states that the maximum angle of elevation for a rescue ladder is 72 degrees. So we have our ladder is here, our building is here. I'm going to redraw this because they have a messy thing going on there. 72 degrees is the maximum angle. Why don't they want it steeper than 72 degrees? Why wouldn't they want the ladder to be steeper than 72 degrees?
Because then that is just stupid. Because then you'd be like super close up.
Yeah, so you guys have all seen where they have a ladder that will like swing like and go back the other direction and won't be attached to the building. Like, have you seen in movies where they'll climb up the ladder and then it will fall backwards?
Yeah.
If you have a 72-degree angle, the weight that you are on the ladder could cause the ladder to go back the other direction. Does that make sense? And then you would fall off and it would be really bad. So 72
I don't know
degrees
if it'll
is
be
the
that bad.
regulated, what?
I don't know if it'll be that bad.
Depends on what you hit. If you hit a tree, you might be able to like jump onto a branch or something and like it would be kind of softer than cement down below, but depends.
What if you
So-
have a helmet on?
Do you scale ladders with a helmet on always?
I mean, you're
Okay.
supposed to if you're
Okay.
in construction.
If a fire department's longest
They're going
ladder
about
is
safety regulation. They have to have a helmet on.
110 feet. What is the maximum safe rescue height? So they're asking from here, from here to here. They're asking for that. We'll call it X. Okay. So 72 degrees is this angle right here. We are looking at X and 110 in relationship to 72. So X is going to be the opposite. 110 is the hypotenuse. Yeah? So which trig function are you going to use? Sine. Sine of 72 is going to be equal to opposite over hypotenuse. X over 110.
Did you have big numbers?
So
Little big.
multiply by 110.
Yeah.
X equals, make sure still in degrees, 110 times sine of 72.
Yeah.
That's not right. Number 8 is whack.
What?
110 sine of 72.
Sorry.
What is altitude?
10 or 110?
Oh, I
110
bet this equation's on our notes, ain't
times
it?
sine
Altitude of an isosceles triangle.
72.
104.6
Why is it not on here?
feet.
She won't give it.
I'm not going to give it to you.
I'll find it in the
104.6.
book.
It's right in number examples next on. The angle of elevation.
Okay, good.
Mhm.
No, it's not.
All right.
Angle of elevation should have
Find the altitude of the isosceles triangle.
At a point 200 feet from the base of a building, the angle of elevation to the bottom of a smokestack is 35 degrees, where the angle of elevation to the top of the smokestack is 53 degrees. So we have these two things going on. We've got the small angle of elevation. This is 53. 200. No, wrong. That's not labeled right. This is 20 or 35 and 200. And then we have
Wait, it's fine.
the larger angle, 200 and 53. Okay? They want to know what the length of the smokestack is, which basically is the length that's added on to here. It's like this length right here where he's cut off. Does that make sense? I'm trying to find the length of that smokestack. So,
I have a question.
I'm not going to answer you.
No, like,
Just wait.
No,
Just
like,
wait.
No, like, I need you
What?
to answer this
What?
question. Is altitude the height?
Altitude? Yeah.
It is?
Yeah.
So like, if you
Like
have
straight up.
Okay.
Okay. So I need to know that distance, which they call S. So what I'm going to do is I'm going to find the length of this side, the length of this side, and I'm going to subtract them. Does that make sense to find that? Okay. So 35. We want to know, let's call this guy X, and let's call this guy Y. All right. So X is opposite, and 200 is adjacent. So we're going to use tangent. Tangent 35 equals X over 200. Okay, then multiply by 200. Do you remember, have we done this before?
140.0.
Keaton? Have we done this before? Have you done this before with me?
So.
Yeah. Yeah, okay.
140.
140 point, what?
Oh.
Point zero? 140.0. That's this distance here, 140.0.
Teachers, please dismiss the cross-country runners.
Okay, now same thing for this big one. 53, we have opposite and adjacent. So tangent of 53 in this case is going to be equal to y over 200. Still multiply by 200. So kind of the same thing again, but it's tangent of 53 instead of tangent of 35. What's that y value going to be? 200
Can you like
tangent
scoot over
53.
just a hair? Yeah.
200 tangent 53.
200 times the tangent of
265.4. Okay, feet. And then we want to adjust the smokestack. So we're going to subtract those two. So like something like 125.4 feet. Is that right?
But you put them on water, bro.
If you subtract these two.
Sure? Yeah, why?
Yeah.
Yeah? Okay. That's the height of the smokestack. Alright, so they might do something like that to you where you have to subtract them. Okay? Alright, couple more. Three more. No. Yeah, 3 more. Alright, a swimming pool is 200 meters long and 12 meters wide.
You want me to do
No,
4?
20 meters long, 12 meters wide. The bottom of the pool is slanted, so the water depth is 1.3 meters at the shallow end and 4 meters at the deep end. Okay? Find the angle of depression at the bottom of the pool. They want to know this angle right here.
100%.
So, if you, I'm gonna draw this a little bit bigger here. You have, I'm gonna really exaggerate some of these angles.
How much do you remember this?
Hold on, what?
Remember this?
What is that? Don't do that. Don't do that. Okay, 20 meters from there to there. So that this means this distance is 20 meters. 1.3 is here, and from here to here is 4 meters. So do you see where they have it labeled 2.7? How did they get 2.7 from here to here?
What?
How did they get 2.7? How did they get that triangle? That side of the triangle is 2.7.
I didn't even do anything.
Do you know?
What are you asking?
How did they get that edge of that triangle is 2.7?
Like the side of it?
Uh-huh.
Okay, so
Oh,
what is this?
because
Is
you
this
take
is the
4
pool.
minus the
Yeah,
1.3.
4 minus 1.3. Okay.
Oh.
So do you guys see what's happening with this pool here? This is the shallow end. Here's the water. This is the shallow end on this side, and the deep end is over here. It like slants down, you know. Okay. So they want to know the angle of depression right here. They want to know what that angle is. So this one you're going to do a little bit different. Okay. If I'm looking at that right triangle, I have the sides that are 20 and the side that is 2.7. Make sure that they're both in the same units. They are both in meters. Otherwise, you have to convert first. So kind of put a little reminder in your brain. They have to be the same units. Otherwise, this doesn't work. So 2.7 and 20. 2.7 is the opposite. 20 is the adjacent. Opposite, adjacent. We want to use tangent. And tangent of what?
Yeah.
What do we do tangent of in this case? X. We're going to call our angle X. Okay.
Is the angle? Okay.
Opposite is 2.7. Adjacent is 20. Okay, now we're trying to solve for that x, and x is inside of the tangent. How do we get rid of the tangent?
Divide by x.
Nope.
Divide
We do the inverse tangent.
I have a
Okay,
question on
you
the
can't divide by
inverse.
tangent because the x is stuck inside of that. So to get rid of him, we do inverse tangent. So inverse tangent, you want to make sure you're in degrees. 2.7 divided by 20.
Is it just
This whole section, you're going to want to make sure you're in degrees.
I have a
Whole
question
section.
that's
What?
good for notes.
What?
So if you have an angle of elevation, right?
Uh-huh.
And your tree is right here. The shadow's like this. Is this the angle of elevation?
The elevation is right there, yes.
Yeah.
Okay. Inverse tangent 2.7 over 20. Do we get an angle?
7.6.
We'll do 7.7. Is that what it rounds to? 7.7 degrees. That's my angle of depression. So just a gradual slope, not a real big angle. Okay. All right. Bearings. Physics people probably had this before. Oh, there's only one example left. Bearings. South 35 east means 35 degrees east of the south direction. So you read it like kind of backwards-ish. It's 35 degrees east of the south direction. Okay?
Oh, I hated
So 35 degrees east of south means you start by going the south direction, but you're 35 degrees on the east side of that. So that's what that looks
That's not
like.
how
Does that
we
make
do
sense?
What was the answer on the first one?
What?
That's not how we did it.
Okay, now, 35 degrees east of south is the same thing as, if that's 35, then this guy would be 55 degrees, right?
South of east.
Okay, this guy would be 55 degrees south of the east direction. Those two things will get you to the same place. Does that make sense? Okay, you're either going south of the east direction or east of the south direction, but they're different degrees. So both of those things mean the same thing. Okay, so let's go down here. Example, here we go. Example. A ship leaves a port at noon, and I'm pretty sure that's where A is at. So this is the start. Okay, it's starting there and heads due west at 20 knots or 20 nautical miles per hour. At 2 p.m. it changes course. So it's going at 20 nautical miles per hour for 2 hours, which they label as 40 nautical miles. So this side is 40. They're going for 2 hours at 20 nautical miles per hour, okay? Then it's changing course and it's going 54 degrees west of the north direction. That's this angle right here, 54 degrees, okay? If they're going 54 degrees that way, what's this bottom angle down here? Do you know? 54 degrees is this top guy. What's the bottom guy going to be?
54.
What? 90 minus 54, which is
I don't know.
36.
Yep.
36 degrees will be that angle. Okay, I'm going to label this because it might help us later on. Find the ship's bearing and the distance from the port of departure at 3 p.m. So they change course and they're going that far. At 2 p.m. is when they changed course. They want to know at 3 p.m. So that means they're going this way for 1 hour at 20 nautical miles. So that's where that goes. Okay. Since this is calculus, I'm going to bring this up because this is something that all other math classes don't take into consideration, but calculus does. 20 nautical miles is not technically how far this distance is going to be. Okay? If you are going 20 nautical miles for an hour, it will be close to 20, but it's not going to be exactly 20. Why not?
Going faster. I can't do it.
20 nautical miles is like the speed that you're going the entire time. You're going to lose just a little bit of distance by speeding up, slowing down, right? Because you're going to speed up, slow down as you're turning, right? Does that make sense? And another thing, you're not going to go straight and you're going to go right away. You're going to do a rounded turn, okay? So this problem does not take into consideration that we're speeding up, slowing down when we round our corner. And it's not rounding the corner. It's saying we go and like change course like at a sharp angle, which is probably not realistic. Going forward, calculus is going to start taking that stuff into consideration, that speeding up, slowing down is not going to make it exactly 20 or 40. And it's going to be a rounded edge versus a straight, sharp edge, okay? So that's what we start to consider in calculus. Not for this problem. This problem is going to just say we're going to be close enough. So they want us the bearing. So they need to figure out the distance of this guy right here. Okay. So let's see. We've got two right triangles going on here, and I'm going to shade them so you guys can see how this is working. This little right triangle here is this guy. We know that this side is 20. This is 36 degrees. Something of that nature.
You're wrong.
Yeah. Okay. Then we have a long. I'm gonna do a different color. Okay. Then we have an overall big one, which I'm gonna label in green, and he's a really, really long triangle.
No.
Okay. And really, what we're trying to do is find this
Look at the drawing.
this side of that green triangle. Okay. The green triangle goes all the way from here to here. Okay. Now we know that from here to here is about 40 nautical miles. We know that this is a 90-degree angle. Both of those guys are. And that's probably about all that we know for the big green triangle. We know that part of that bottom side is 40. So let's try to do some things and solve some things on the small triangle so that we can label them on the large triangle. So let's find this guy down here. Okay, let's call him X.
Figure it out.
Okay, so 36 degrees is my angle. X is going to be my adjacent side, 20 is my hypotenuse side. Adjacent, hypotenuse. This guy's the opposite. So if we want adjacent hypotenuse, let's do cosine of 36 equals, the adjacent is X, the hypotenuse is 20. So multiply by 20. And what's cosine of 36 times 20? Or 20 times cosine of 36? What's that? 20 cosine 36. What is that?
You get 80.7.
Is that how you do it?
What?
20 cosine 36. Let me do that.
Times the cosine of 36.
16.1.
What?
16.2.
16. Yeah, we'll go to the nearest tenth. Okay, 16.2 is this distance right here, which means that this distance right here is also 16.2. Does that make sense? Yeah. Okay, so the entire length from here to here is 56.2. That helps us solve that bottom side of that triangle. Okay. Now let's find this side guy also, which is going to be the same as that one. Okay, so let's find the side guy. So he is opposite and hypotenuse. So opposite hypotenuse is going to be sine. If we do sine of 36, we have the opposite over 20. If we want to know that opposite guy, and we do times 20, 20 sine of 36, what's that going to come out to be? 20 times sine of 36.
20 times the sine of 36.
Yep.
11.8.
11.8. So this guy is also going to be 11.8. Okay? Good? All right, so now I know a little bit more about this green triangle right here. What I really would like to find is this side. And I can really find that side right now if I wanted to, because this is a right triangle. We haven't done this yet, but Holly mentioned it earlier. If it's a right triangle, we can do the Pythagorean theorem, right? So I have 11.8 and 56.2. So 11.8 squared plus 56.2 squared is, we'll call this guy side C, C squared. Okay, so we need some calculations and such.
Okay.
11.8 squared. 11.8 squared. I'm going to do plus 56.2 squared.
57.4.
This guy is 3297.68 equals C squared. And if I square root those,
57.4.
57.4.
Shut down too.
Okay, so 57.4.
Like for real, for real?
Yeah.
Why aren't we? Our boys were exposed.
No. There's like, they closed school down?
Like just now posted on
No.
Madison story. See everyone in 2 weeks. As
Gross.
he's looking off the camera.
Well, that doesn't mean they closed down. That means like she individually might have to
Well,
quarantine.
I bet so like.
And why is she with
Uh.
3 people?
I don't know.
I
maybe.
think their Facebook page.
Okay, now we want to find this angle. I'm going to use the 11.8 and the 56.2. So we have the opposite and the adjacent. So tangent. Tangent of x, we'll call it. Opposite is 11.8. Adjacent is 56.2. So we're going to do inverse tangent to get that x out of there. Inverse tangent 11.8 divided by 56.2.
Yeah, they said they have corona.
And I got, that's not right.
That was a close call.
Did somebody else do it?
Um,
Did you get 11.8?
yeah, I did, but
That's
that
weird.
seems weird.
Yeah. So the angle is 11.9 technically degrees. Okay, so let's talk about this. This angle right here, if we're doing like the distance that the boat traveled, right? The distance the boat traveled was 57.4. He is 57.4 nautical miles. And how do we call that angle? This is 11.9, but what's the bearing of this ship? The ship is over here. 11.9 is that guy. What will we call him? 11.9 degrees what? So if this is my coordinate plane right here, he is what of what? Here's north, south, east, west. He is what of what?
What's the degrees? That's 11.9.
Mm-hmm.
11.9 degrees north of west.
So he
No,
is
okay, they're not
57.4 nautical miles at
Luke Swanson.
11.9 degrees. What?
But Morgan has
What did you
it.
say? When?
11.9 degrees north of west.
North of west. So in the west direction, then you turn and go 11.9 degrees north. Does that make sense? That's how you write it.
76.
Or you can say 57.4 nautical miles at this angle right here would be 78.1.
No.
You could say 78.1 degrees west
What was
of
your
north.
first answer that you got?
Does that make sense?
No, because I erased
So
it
it's
all.
west of the north direction versus north of the west direction. Either one is fine.
This is
I have
where
like
I'm
4
not gonna
answers.
sail a boat.
It's like a
Okay,
central.
that's it. That was a lot of information. Holy cow.
Are you
Show
sure?
me. Right here.
You rated for
Did you
both.
get lost in
No,
that? Or
no,
you're
like-
you're gonna get lost if you make
Yeah,
we
if I
have to sail a
get
boat.
lost
Okay.
at sea, some
Got it.
stuff
All right, everybody say bye, Liddell.
go.
Goodbye.